Bismillahirrahmanirrahim. Assalamu alaikum. I'm Dr. Seemal Jelani from Chemistry Department, and this fall I'm offering this MPhil course, Chem 542, which is the Advanced Organic Spectroscopy. Now, this course is highly technical course, and this course will help those students who are aiming to opt natural product research in natural products, structure elucidation, synthesis, and so on. Especially, I can say that drug analysis and research related to something new which you create or which you synthesize. So you need to have these skills because this is the technical skills which everyone knows before diving into the research oriented activities. So if I talk about the course contents, so basically we are going to study in detail the two important techniques. Number one is the mass spectrometry and number two is the NMR. So these are the two things. So let me give you some basics of this mass spectrometry. So ultimately, we need to get the skills or to understand the strategic approach to analyze this mass spectra as well as how to solve the problems. And to understand this thing or to get the skills, we need to understand the basics of the mass spectrometry. So in the first 2 weeks, I'll give you some introductory, introductions or some introductory information regarding the basics of this mass spectrometry. It is based on the fragmentation and structural analysis. So we'll go for some initial ionization techniques and the fundamentals of the fragmentation, right? So two things are very important in this course. Number one is the Stevenson's rule, and number two is the McLafferty rearrangements. So we, after studying these things, and of course, one thing is very important, and that is the ionization techniques. What are the different ionization techniques? We'll go for some common methods like desorption ionization techniques, like SIMS, FAB, and MALDI. And we go for the physical ionization as well as for the chemical ionization. After that, we study the fragmentation patterns, and two very important things are there: Stevenson rule and McLafferty rearrangements. When we get this information about the mass spectrometry, then we study the common, the how these fragmentation patterns work in hydrocarbons, in alcohols, phenols, ethers, thiols, carbonyl containing compounds like aldehydes and ketones, and esters, carboxylic esters, and so on. So the what I'm expecting from my student and what is my goal in this? I'm expecting that student may be able to solve the spectra. They must understand how to interpret the spectra. So this is a very accurate technique, and you can find the molecular weight and you can draw the structures and so on. You can use the different softwares in this thing, like ChemDraw, ChemSketch. So the ultimate goal is to teach you how to understand the strategic approach to analyze the spectra and how to solve the problems. Second part of this course is the NMR. There are two types of NMR we are going to study. Number one is the proton NMR, and number two is the carbon NMR, C13 NMR. So most commonly it's the proton NMR because carbon 13 NMR, it's carbon 13 is a very rare. So most of the time we spend or we can go for the extensive digging to understand the proton NMR. Now here we are going to learn the basic things for the NMR. Before understanding the spectra, we need some theoretical strong skills to understand these NMRs signals. First, we go for the different points like what is meant by nuclear magnetic resonance spectroscopy, and what is actually meant by the resonance, what is meant by the chemical shift, what is meant by shielding and deshielding, what is the magnetic anisotropy, what are the different factors which affect on all these things. The most important is the electronegativity and hybridization effects. Then we go for the spin splitting, n plus 1 rule, Pascal's triangle, and the different NMR, how the different classes they absorb NMR. So we also need to understand the chemical shift, what is meant by the upfield, what is meant by the downfield, what uh, which standard we use normally, and so on. So actually, basically, there are some factors which affect all these things. So we need to have very strong grip on these factors. So after studying the proton NMR, we go for the, carbon 13 NMR, and there we can study a lot about carbon 13. What is actually carbon 13? Like we go for the tricks and tips to solve carbon 13 NMR. We also go for the homo and heteronuclear um, things, and so on. Then we finally go for the um like what I say, that the correlation spectroscopy 2D NMR. So it includes HOMO, it includes proton COSY, it also include TOCSY, totally correlated spectroscopy, but we simply go for the two dimensional NMR, which is the COSY, and we go for some examples which express this COSY. Now, this is actually the technical, course, highly technical course, and the ultimate outcome is that you may be able to solve the spectra. For example, if you synthesize something new, then you have to go for the NMR and mass spectrometry. So you need to have these skills, so that you can use the skills and predict that what kind of compounds could be present in your could be present. Um, if I talk about the assessment is uh, like simple quizzes and mid exam, final exam. But there are two main things which I am including over here. Number one is the spectral technical information about the spectra. So when we go through the different classes of organic compounds, I'll give you some spectral analysis, and you need to solve them. So these activities will be including under the technical assessment. And for the normal assessment, you can go for the quizzes, where you can discuss quizzes, two, maybe three, maybe four, depending upon the time, as well as to what extent you are understanding the things. So this is about the course, all about the technical information about the course, and I hope you will like this course. I'm teaching this course. This is my second time I'm teaching this course. You are the MPhil students, mostly students you come from the different universities, and I really say this thing, that you will definitely enjoy this course with me, because it's not the rote learning in this course. We need to understand, we need to build up some skills and some expertise, so that we can use those skills and expertise in the research oriented activities. So I welcome you for this course. You can register my course, and see you inshallah soon. Thank you so much.